In the vast, swirling disk of the Milky Way nearly 5 billion years ago, something extraordinary was about to happen. In the cold clouds of dust and gas, a star was preparing to be born. This star would become the center of our solar system, our sun. Its story is not just one of light and heat, but of cosmic drama, transformation, and eventually a silent dark end. Today, we embark on an epic journey through time, from the sun's fiery birth to its inevitable death as a black dwarf, and the mysterious possibilities that lie beyond. Phase 1. The birth of the sun. The story of the sun begins in a giant molecular cloud, a dense cold region space, filled with gas and dust, primarily hydrogen and helium, the building blocks of stars. One such cloud, known as a stellar nursery, was disturbed, perhaps by a nearby supernova explosion or gravitational waves rippling through space. This disturbance triggered the collapse of a specific region of the cloud. Gravity took over, pulling the gas and dust inward, forming a dense core known as a protostar. As the core collapsed, pressure and temperature at its center increased dramatically. This phase lasted tens of millions of years. Eventually, the core reached a critical temperature, about 10 million degrees Celsius. At this point, hydrogen atoms began to fuse into helium, releasing vast amounts of energy. A star was born. This was the birth of our sun, a G-type main sequence star, or G-dwarf. It lit up, and the solar wind blew away the remaining gas and dust, carving out the early solar system. Planets began to form around it. Earth would eventually become home to us. Intelligent beings who would one day gaze back at this star and wonder about its fate. Phase 2. The main sequence, the sun's prime. For the next 10 billion years, the sun settles into what we call the main sequence phase. It's the long, stable period of its life, during which it burns hydrogen into helium in its core. Right now, our sun is about 4.6 billion years old. It's in the middle of its life. Its gravity perfectly balances the outward pressure from nuclear fusion. This balance, called hydrostatic equilibrium, keeps the sun stable, providing a steady stream of light and heat to the solar system. This phase supports life on Earth, but even in its stability, the sun is changing. Every second, 600 million tons of hydrogen are fused into helium. Slowly, the core builds up helium ash. As the hydrogen runs low, the core will contract and heat up. The outer layers will respond by expanding. The balance will break, and a new phase will begin. Phase 3. The red giant, the sun's transformation. In about 5 billion years, the sun's core will have too little hydrogen left to continue fusion. Without this fusion pressure, gravity will make the core collapse. As it shrinks, it heats up, and a shell of hydrogen around the core will ignite in a new round of fusion. This will cause the sun's outer layers to swell dramatically. It will become a red giant. Its radius will expand, engulfing Mercury and Venus, and perhaps even Earth. The sun will become hundreds of times larger than it is now, but much cooler on the surface, giving it a reddish hue. Inside, helium fusion will begin, fusing helium into carbon and oxygen. But this phase will be short-lived. The sun does not have enough mass to fuse heavier elements. Eventually, the helium will run out and fusion will cease. Without any more fuel, the sun will be unable to hold up its outer layers. Phase 4. The planetary nebula and white dwarf. When fusion ends, the sun's outer layers will be blown off into space, creating a spectacular planetary nebula, a glowing shell of gas, spreading into the cosmos. At the center of this nebula will remain the sun's core, a white dwarf. This is a stellar ember, hot, incredibly dense, and no longer undergoing fusion. Roughly the size of Earth, but containing half the sun's original mass, it will shine from residual heat. Over billions of years, the white dwarf will cool and fade. It will no longer produce light. It will become invisible to the naked eye. This is the sun's final state, a black dwarf. Phase 5. Black dwarf, the final remnant. The black dwarf is a hypothetical object. Because the universe isn't old enough for any white dwarf to have cooled that much, but we can predict what it will be. A black dwarf is a cold, dark stellar corpse. No light, no heat, no activity. Just a carbon-oxygen remnant, floating silently through space. It will no longer influence the solar system if any of it still exists. Its gravity will remain, but it will be inert. No fusion, no flares, no life-giving energy. But is this truly the end? Phase 6. Beyond the black dwarf. Theories of the end. What happens after the black dwarf stage depends on the nature of matter itself. Theory 1. Proton decay. Some grand unified theories suggest that protons, the building blocks of atoms, may not last forever. If protons decay, the matter in the black dwarf will gradually break down into radiation. Over unimaginable time, up to 1,000 years, the black dwarf would evaporate into light particles. Nothing would remain. Theory 2. Gravitational encounters. In the far future, galactic interactions or passing black holes might consume black dwarfs. The sun's remnant could be swallowed by a black hole, adding its mass to the abyss. Theory 3. Black dwarf supernova. A highly speculative idea suggests that black dwarfs may eventually undergo explosive nuclear fusion from quantum tunneling, called a black dwarf supernova. This would be the last firework in the universe, but only after 10–1500 years. That's beyond any timescale we can comprehend. Theory 4. Eternal fossils. If protons are stable and no strange interactions occur, black dwarfs could remain as cold fossils forever, drifting through a dead universe. Phase 7. The heat death of the universe. The story of the sun is tied to the larger fate of the cosmos. If the universe continues expanding forever, it will undergo heat death. Stars will all die. Black holes will evaporate through Hawking radiation. All energy will spread thinly across space. The universe will be dark, cold, and quiet, a state of maximum entropy. In this cosmic graveyard, the black dwarf, the remnant of our sun, will be one among countless stellar ghosts. But even in this silence, there is wonder. The sun, like every star, is a brief flare in the darkness, a moment of warmth, of creation, and of life. We are children of the sun. Every atom in our bodies was forged in stars like it. Its story is our story of birth, of transformation, of eventual stillness. From a glowing infant in a gas cloud to a silent black dwarf in a dead universe, the sun's journey is long, complex, and humbling. So next time you look up and feel its warmth on your skin, remember you are witnessing just one chapter in a tale, billions of years in the making, and still unfolding. This is the life of the sun, a spark, a furnace, a giant, an ember, and finally, a whisper in the dark.